Welcome to today's lesson. I am Jamasaka Kendins. And so today I'm going to take you through a lesson in physics and we'll discuss power. So we go straight into the lesson. Actually, power is the work per unit time. So in other words, we're saying if we have a device and that device does work per second, it means that actually it is doing work. And so we can redefine work as the rate at which a device transfers energy from one form to another. So this is very important because it is not only work, so it can also be energy, which is actually transferred from one form to another, within the actually per second. And so the average rate at which work is done is actually power. So power is actually a scalar quantity because it has only size and no actual direction. So it has only magnitude and it has no direction. So because actually the work and the time which define power are actually scalar quantities, and therefore even power itself is a scalar quantity. It's a quantity which actually um, has no direction. And so the most important things here to note are that actually power, we need to look at the rate at which actually a device transfers energy from one form to another, or it is actually the rate at which work is done. In other words, we are saying actually power is equal to work divided by time. And we also further explain that actually we said that actually power is actually a scalar quantity because it has only magnitude. So what is there is only magnitude. So actually power has only magnitude, and that's why it is a scalar quantity. And so the definition for power in terms of the formula, we said actually power is equal to work over time, where actually the power itself is expressed in joules per second because actually the work here is in joules. And then the time is in seconds. And therefore, it can be expressed as joules per second. And joules per second is actually a quantity which is known as the watt. I've already expressed that actually work is in joules and the time is in seconds. So this is a basic equation which can enable us to calculate power. And so again, we said actually power is equal to energy transferred over time. And we note that this energy, which is transferred, should be in actually joules, should be in joules, and the time should be in seconds. Okay. So we are saying again, similarly, the power will be expressed in joules per second or watts, and the energy transferred will be expressed in joules, which is actually capital J. And the time will be expressed in seconds. Okay, and so these basic units are very important to understand that actually 1000 watts will give you 1 kilowatt. Kilo means 1000, 1 kilowatt, and 1 kilowatt is the same as actually 1000 joules per second. And 1 horsepower is equal to 746 watts. This is very important because at times certain questions require conversions. And so we need to be able to convert to appropriate units when we ask to. And so we are saying actually power is equal to work divided by time. And we know that work is actually force multiplied by distance divided by the time. And so we know that this is equal to force multiplied by, as we know, distance over time is actually speed. That's where it is here. And so at times, again, this force can be equal to mass multiplied by acceleration multiplied by the speed. Okay, and so you notice that here, when we express power in this form, we are saying actually the mass here will be in kilograms, and the acceleration will be equal to meters per square seconds, and the distance there, which comes from the speed, distance over time, it will multiply to give us actually meter squared. And this one, this t from the speed and the squared t from acceleration will give us actually second cubed. Okay, second will be cubed. And so these are also units for actually power apart from the joules, second, or the watts. So at times power can be expressed in these units. And so now that we have learned the basic concepts on how we can calculate power, we can go straight away and make calculations on these basic equations just to enable us to understand what power is. The first equation goes as follows: a car stops 90,000 joules of work is done by the brakes to stop it in 4 seconds. Calculate power of the brakes. So power is equal to work over time, which is equal to 90,000 joules divided by 4 seconds, which actually gives us 22,500, 22,500 watts. Okay, so which would be equal to, if we divided this by 1000, it would actually give us 22.5 kilowatts. And so this is very basic indeed. It has just helped us to know how we can plug in the given variables and it gives us actually the answers as we have done. And so we were given these, um, actually the work and the time, and we just plugged them, and then we are able actually to find the power in watts as well as in kilowatts. So the second part of the question goes as follows. How much work is done in lifting a box that weighs 100 newtons to a height of 10 meters? And the second part, at what rate is work done if the 100 newtons is lifted to the height of 10 meters in 2 seconds? And so the first part of the question, we can say actually we are asked to find work, and we know that work is equal to force multiplied by distance. And the force, 100 newtons. So the force is 100 newtons multiplied by the distance is 10 meters. The distance is 10 meters. And so this gives us 1000 Newton meter, which is equal to actually 1000 joules. So we have calculated the first part. So we have known what the work is by merely multiplying the force and the distance. So the second part of the question is asking us actually to calculate power. We know that power is equal to work over time. And we know that we have already calculated the work, which is 1000 joules divided by the time we are told in 2 seconds. So we have 2 seconds. When we divide this, it gives us 500 watts. 500 watts, which is equal to 500 watts divided by 1000, which is equal to 0.5 kilowatts. Okay, so this is actually our power. We go to the third question, which is actually also a basic question just to enable us to understand the question. A bag is moved through a distance of 20 meters horizontally by applying a force of 400 newtons. Find the useful power developed if the bag was moved in 10 seconds. And so we know that actually power is equal to work over time. And this work can be actually expressed as force multiplied by distance over time. And so we are given that the force is 400 newtons. The force is actually 400 newtons multiplied by the distance is 20 meters. Note that the distance is 20 meters and the time is 10 seconds divided by the time, which is 10 seconds. And so when we calculate this one, it gives us actually 800. We can divide 10 here, 1, 10 there, actually 2. It gives us 800 watts, okay, which is equal to 800 watts divided by 1000, which gives us 0.8 kilowatts. And so I thought we would actually today look at the concepts on how we can calculate power. And this is very important because it has helped us to understand that actually we are able to manipulate the formula for power, which is equal to work over time, by actually looking at this work, which can be expressed as force multiplied by distance over time. And so I thought with these basic concepts, they can actually enable us to calculate more complex problems in physics. And so I urge you to subscribe to my YouTube so that you can continue learning of these new actually lessons. I thank you.